The third and final part of this lesson is to factor a special case called the difference of two squares. Difference, which means subtraction, and we have two perfect squares, a squared and b squared, is factored to the quantity a plus b times the quantity a minus b. Let's take a look at the example. We have a subtraction sign, so that means we have a difference. X squared is a perfect square because the exponent is even, and 1 is also a perfect square. Remember, there's an understood 1. And 9 is a perfect square because remember, 3 squared, or 3 times 3, is equal to 9. Therefore, this is factored to equal x plus 3 times x minus 3. We could always check it by using the distributive property. The quantity x plus 3 times the quantity x minus 3 is equal to the first term in the first factor times their entire second factor, the second term in the first factor times their entire second factor. Remember, you must always bring down the plus sign. If this was a minus, we would bring down the subtraction sign. All we have to do now is distribute. X times x is x squared. X times a minus 3 is minus 3x. Plus 3 times x is plus 3x. And plus 3 times a minus 3 is minus 9. Combine our like terms, we have x squared minus 9. Let's take a look at another example. X squared minus 81. We have a subtraction, we have a perfect square, as well as another perfect square. So this is the difference of squares. Remember, the coefficient in front of x squared is a 1. 1 is a perfect square. 1 times 1 is 1. The answer for this one is equal to x plus 9 times x minus 9. Let's take a look at another example. We have a subtraction sign, therefore 1x squared is a perfect square, and 144 is also a perfect square. We can write x plus 12 times x minus 12. Let's take a look at another example. Since the first term is a perfect square, the second term is a perfect square, and we are subtracting, we could write our answer as quantity x plus 13 times the quantity x minus 13. X plus 1 times x minus 1. Can you tell me the solution to this particular problem? Would this be the solution? Hopefully you notice that we have a plus sign, so therefore this is not the difference of two squares. If we took a closer look, 1 times 16 is 16. We would like to have two numbers in which we multiply to get 16, but when we add, we get 0. 4 and 4 will give us 16, but if we try to get the 0, the only two numbers that could possibly work would be 4 and negative 4. But 4 times negative 4 is negative 16. Therefore, this is not the solution. The solution is simply x squared plus 16. Let's take a look at another example. First, notice we do have a subtraction sign, so we do have a difference, but unfortunately 2 is not a perfect square. 18 is also not a perfect square. But notice, the first term has a factor of 2 as well as the second. Therefore, we could factor out the 2. When we take a look inside the parentheses, notice we still have a subtraction. The first term is a perfect square. The second term is also a perfect square. The square root of x squared is x, and the square root of 9 is 3. 2x squared minus 18 factored completely is equal to 2 times the quantity x plus 3 times the quantity x minus 3. Let's factor. Notice we do have a subtraction sign, but the exponent is odd. Therefore, the first term is not a perfect square. The second term, 81, is a perfect square. The exponent of the variable is a 1. Since 1 is an odd number, the second term is not a perfect square as well. We can factor out an x since the first term has 3 x's and the second term has 1x. Now let's check inside the parentheses. Subtraction is still there. First term is a perfect square since the variable has an even exponent. The second term is a perfect square since the square root of 81 is 9, or 9 squared is 81. Therefore, we can factor the difference of squares like so. Let's take a look at the next example. Notice we have an subtraction sign, so we have a difference. Since the 5 is not a perfect square, 5x cubed is not a perfect square. Or we can say since the exponent is odd, 5x cubed is not a perfect square. Let's take a look at the second term. Since 20 is not a perfect square, we know that 20x is not a perfect square. Or since the exponent is odd, 20x is not a perfect square. We can factor out an x. We have 3x's in the first one, 1x in the second term. Therefore, we could factor out 1x. We could also factor out a 5. Since 5 is a multiple of 5 and 20 is a multiple of 5. We can now factor the binomial inside the parentheses, and we will get 5x times the quantity x plus 2 times the quantity x minus 2. What would be the first step in simplifying this particular problem? Both terms have a factor of 2. We can factor out a 2, leaving us with x squared plus 25. But notice that this is an addition. It is not a difference of squares. Therefore, our final answer is just 2 times the quantity x squared plus 25. Let's solve by factoring. First, we'll GCF factor. We'll factor out a 2. Notice that we have the difference of squares now. A perfect square subtracted from another perfect square. Therefore, this is a difference of squares, which can be factored out by writing 2 times the quantity x plus 10 times the quantity x minus 10. And now we can solve using the zero product property. X plus 10 is equal to 0 and solve. X minus 10 is equal to 0 and solve. Our answers are negative 10 or 10. Let's solve by factoring. We can GCF factor first by factoring out a 2x. We now have the difference of squares, which can be factored as 2x times the quantity 3x plus 5 times the quantity 3x minus 5 is equal to 0. We'll set the first factor equal to 0 and solve. We'll set the second factor equal to 0 and solve. We'll set the third factor equal to 0 and solve. Our answer is negative 5/3, 0, or 5/3.